Set theory, proper subsets, the definition of proper subset, as well as example 4. Okay, a proper subset is a subset that is not identical to the original set. It's going to contain fewer elements than the original set. So as far as notation goes, if set A is a proper subset of B, we write A, and I guess if I wrote that a little bit better, it's probably pretty sloppy there. It looks kind of like that. So, however, if A and B were equal sets, then A would not be a proper subset of set B. Okay? So the biggest issue for my students here is remembering the difference between the notation of a set, a subset, or a proper subset. So that might be something that you start to think about and try to figure out the difference in your head. So one of the examples that I've given to students before is with just the regular subset. You'll notice that we have the line under here. Maybe that could symbolize, you can also include the one that's equal to it, whereas a proper subset just has this symbol. So if you feel like you're going to have a problem with that, you might need to make some note cards and review yourself on the items that you might have a little bit of trouble with. All right, so example 4, they want us to use the sets from example 3. So we're looking at sets A, B, and C up here. And so example 4A says, is A a proper subset of itself? Well, no, because they would be equal, right? A set cannot be a proper subset of itself. So that's a no. So if they asked if A could be a subset of itself, absolutely. It just can't be a proper subset of itself. So they're asking if B is a proper subset of A. Well, it looks hopeful because B is smaller than set A. It has fewer elements, but let's make sure that it's actually a subset. So 0 is part of A, 6 is part of A, and 12 is also part of A. And again, they don't have the same elements, so that is a yes. Okay, set B has fewer elements than A. All right, set C, is that a proper subset of B? No, because I think you'll notice that 12 is an element of set B, so is 6, and so is 0, and that accounts for every single element. Remember that B and C were equal sets, so that is a no, because set C has every single element that set B does. They're equal sets.